Well, good morning, everybody. This is the beginning of the productivity webcast series. This is the first webcast in this series. Today we're going to talk about some of the benefits of moving from from AutoCAD to Map 3D. Some of the enhancements, you'll see some of the productivity gains you can expect to get by making that transition from AutoCAD to Map. So here's the Autodesk geospatial value chain. It's kind of a thermometer, barometer, if you will. It allows you to kind of gauge where your company is in this value chain and gauge where you might see more productivity gains for your particular company. At the bottom at stage 1, we've got AutoCAD working with just straight DWGs, lines, arcs, circles, text. When you move up the value chain to stage 2, you get all the functionality of Map 3D, and today we're going to talk about a majority of that functionality that you get with Map 3D. So you get things like the ability to add real-world data to drawing objects. You get the ability to connect to many different data formats, whether it be file-based formats like Esri Shape or database formats like Oracle or SQL. Continuing up to stage 3, you start to work with Map, but then you're sharing with a larger audience using the Autodesk Map Guide and FDO. With FDO stands for Featured Data Objects. You get the ability to connect to and share many types of data through Map and Map Guide to a larger audience. Again, up the value chain to stage 4, we see Map 3D and the ability to work directly with spatial databases, and I talked about that a little bit already, connecting directly to Oracle or SQL and consuming data and also writing data back to those data stores. And then finally, the top of the value chain, stage 5, is Topobase. It's a full design and management, asset management solution, enterprise solution that works with Oracle spatial databases. For any of you that have attended a webcast from PPI on the geospatial track or an Autodesk geospatial webcast, you've probably seen this slide or something similar to this slide, and it's referred to as the donut. And what's important about this donut, what's important to see here, is that data is in the center. And you've got this Autodesk technology around that data, allowing many different users to access that data in the format that they would expect. So you've got your engineering and CAD guys working through AutoCAD or Civil 3D in the DWG environment. You've got your planning and GIS folks working with that data, whether it be in Esri Shape, whether it be in an Oracle database, maybe it's in DWG, doesn't matter. You've got your operations crew, maybe they have a mobile ruggedized laptop. They're connecting through a web portal to a map guide site that gives them information about their tasks for the day. Maybe they're just using, maybe it's not web-based, maybe it's DWF-based. So they have a DWF or set of DWFs in their possession that they can access to get information about what they expect to see in the field. And they can also update that information with what is truly in the field to reduce the inaccuracies between the data in your data store and what's truly in the field. And then you've got the public out there that a lot of times wants information, and typically it's through a web access, a map guide interface site, and you can share portions of that data with the public as well. On top of that, there are these solutions. On top of that concept, there are these solutions from Autodesk that make this scenario possible. And I'm not going to go through all of them, but you'll notice Civil 3D is there, AutoCAD Map 3D. Right at the top of the donut, you've got Topobase with its particular modules. And again, Topobase is a full asset management software that works with Oracle database on the back end. Again, today's webcast is going to revolve mostly around Map 3D and the functionality in Map 3D. Some of the big highlights here: the ability to directly access data, whether it's in CAD formats, GIS formats, Raster formats, doesn't matter. The FDO, the featured data object tools, really give you that ability. Um, you've got the old familiar AutoCAD tools, um, precision geometry creation, editing, all those things that most AutoCAD users are very familiar with. And then you add on top of that the GIS tools, the new tools for map creation, stylization, and you've got a workforce out there that's already very CAD savvy, and you just add to that complement of tools that they have at their disposal for creating map stylization, doing some GIS analysis. Very easy to do. And then publishing this data out to users, multiple users, either via a map guide enterprise site or through DWF. So the value of Map 3D, you leverage the CAD trained workforce and you give them the ability to manage geospatial data. You create better designs, you improve the sharing of data across your network, across your enterprise, whether it be DWG, whether it be Esri users, it's all there. And we'll see that today. So here are the top 10 reasons why you should move from AutoCAD to AutoCAD Map 3D. And we're going to talk about the majority of these reasons in some live demo. So you have the ability to work in real-world context. And what does that mean? That means you have the ability to apply coordinate systems to your drawings and then consume data from many other coordinate systems and have that data translate or transform in those coordinate systems so everything lines up together. For instance, if you have a DWG in a California State Plains and you've got a SID image in a lat-long coordinate system, you can bring those together very easily, and MAP takes care of all the data translation for you. Streamlining data access. You have the ability to access data in many formats, whether it be CAD formats, whether it be GIS formats, and in GIS there are file-based formats as well as database formats. So all those are now at your fingertips with the use of Map 3D. More accurate design data. So MAP gives you a suite of tools referred to as the drawing cleanup tools that allow you to remove many of the errors and inaccuracies that get introduced into a drawing either through drafting or digitizing, raster, or things of that nature. So we'll see that today as well. You have powerful mapping and stylization tools, so you can bring lots of sources of data together and stylize that data to represent different things, to show different things in a thematic way, and then publish that data for other users to consume. As has been mentioned, very sophisticated ability to connect to and work with databases. You have the ability to do some 3D rendering if you've got 3D raster graphics like a digital elevation model or an Esri grid surface. You can bring that data into Map 3D and then drape other data over the top of it, other line work, other images. Maybe you've got a JPEG and a digital elevation model. You can drape that JPEG over the digital elevation model and get a very high resolution, very nice looking 3D elevation model. MAP also gives you the ability to work with a single drawing, multiple users working with a single drawing. So true simultaneous multi-user access to drawings at the object level, and we'll see that as well. You've got metadata, the ability now to add and edit metadata to maintain that metadata that as spatial data is created or edited, that metadata is easily maintained with Map 3D. And then again, you can distribute this data once you've created these maps and brought all this data together. You can distribute it easily to the masses using either publishing to the web through Map Guide interface or publishing to DWF and then sharing that file-based information with users. So let's get to some hands-on, some real world here. So in Map 3D, I've just got a blank screen. And for those of you that haven't seen it yet, this is the Map 3D 2009 interface. One of the biggest changes in Map 3D is the new ribbon. And I choose not to use the ribbon very much just because I'm not familiar with it, but it is there. It's very similar to the ribbon that you see in the new Microsoft tools, Word, Excel, and so forth. I'll stick with the menus and toolbars that I'm familiar with. So in this new blank drawing, as I mentioned earlier, we have the ability to work in real-world coordinates, spatially aware, give our drawing spatial awareness. So let's set up a coordinate system for this drawing. So I'll assign a coordinate system, and I'm looking for a California state plains coordinate system. So I can, and you'll notice that there are many categories, and each category has a host of different coordinate systems in that category. And they all have a specific code defined with them. So if you know the code, for instance, I know that I'm looking for the California State Plains North Zone foot, Zone 1, I'm sorry, I know that the code is CA-I, so I can choose Find, and it picks that out of the list for me, and I can assign that to this drawing. So now this drawing is referenced in that coordinate system. Other data that I bring together can be in other coordinate systems, and it's all going to get translated correctly and be spatially correct in this drawing. So let's see how that works. So let me connect to, again through the FDO tools, some data. So right now we're talking FDO and the ability to consume data of many formats. And let's just talk about these since this is the first time we're looking at this dialog box. We've got the ability to connect to an ARC SDE database. So for those of you out there that have GIS group or planners that work with Esri, you might have an SDE database out there. You can connect directly to that database with MAP and consume data from that SDE database. MySQL is an open source version of SQL. ODBC connections, there are many databases that support ODBC connections, so you can set those up. Oracle, Raster, and we'll do quite a bit with Raster surfaces today. Not only Raster surfaces, but SID Images. I think we do PNG or two as well. You can connect to shapefiles, SQL Server, web feature services, and web mapping services. Web mapping services return to you an image. I believe it's in PNG format, so we'll see that today as well. I'll connect to a web mapping service on the NASA government site. We'll see how that works. So right now I want to start by adding a digital elevation model, and that's considered a raster surface. So let me give it a meaningful name here. I'll get a DEM. Let me just browse out and find that. Here's my Reading digital elevation model, so I can open that up, connect to that data, and see here that it finds that digital elevation model. It also knows what coordinate system, and you'll notice it's a different coordinate system than I set up for the drawing. Excuse me, but that's okay. It's going to do that coordinate system transformation for us. So let me just select that data, and let's add that to the map to start. So there's a digital elevation model, and this, you can get digital elevation models from USGS as well as a few other sources. It's basically a 3D, three-dimensional image. It's got pixels at a certain grid interval that have elevation associated with them. So you'll notice that there's a nice three-dimensional look to this, and it has true 3 dimensions. So if we were to go into a 3-dimensional view, we would see true elevation relief on this raster surface. Let's add a few more sources of data to this. So let's connect to another image, and in this case I want to connect to some Mr. SID images. So a meaningful name for my connection. In this case I want to get a folder. I have a folder out there with some Mr. SID information in it. We'll connect to that, and we'll see the entire list of images in there for us. So here are the SID images. So let's see, the coordinate system here is unknown. I happen to know the coordinate system for these, and again, if we want transformation to happen correctly, we need to apply coordinate systems. So I can globally edit the coordinate system for all of these. And let's set this coordinate system at the California State Plains coordinate system of our drawing. So again, knowing the code, I can just type it in and it will find that for me. So it sets the coordinate system for those SID images, and then I can bring them into the drawing. And as opposed to having all these images on their own layer in my display manager, I'd like to combine them to one layer, and I'll just give it a name of SID. So it adds that data to the map. So there's my SID image, and I can zoom up on that, and we get a little better look at some of this data in the Redding, California area. One more source of data that we can bring in. I've got a digital raster graphic, yet another image source. So let's connect to that digital raster graphic. And it's in TIFF format. Again, needing to set a coordinate system if one is not provided by the image. Some images have the coordinate system embedded in them. Others use a world file that accompanies them. And in some cases, they don't have a coordinate system at all. So you'll need to set that up. In this case, we're looking for USA, California again. But it's the CA-TEAL, the Albers coordinate system. So we'll add that to the map. So what have we done so far? We've set up a coordinate system for the drawing, and then we were able to consume data, images in this case, of varying formats and bring them together, and you'll notice they all line up correctly. They all come together correctly in this map. So map handles the coordinate system transformations for us. All we need to do is set the drawing up correctly. We have the ability now to track coordinate systems. So right now I'm in a UTM 27 zone 10, and as my pointer moves around, you'll notice the X and Y location. I can change this coordinate system. Maybe I'm interested in, I don't know, not a UTM, maybe lat long. And what am I looking for? LL84. There it is. So now you'll notice I am getting echo here of the lat long where my cursor is. Same position in the drawing, but I'm getting different XYs. So I have the ability to track coordinate systems, any coordinate system that map supports, and there are a lot of them, in my map. So true real-world context in our designs. So let's move on now and let's talk about the ability to access other types of data. We've seen the ability to access some images. Let me open a drawing here. And we'll close this drawing. So this drawing is called LL84, and as you might expect, the coordinate system assigned to it is LL84, so this has been set up previously. And this is again something you can set up in your AutoCAD drawing template, and that if you work in a specific coordinate system all the time, then each time you create a new drawing you don't have to think about it, it's just set. So let's bring in some SID files again to start with. And I'll browse to my folder. Again, I want to set the coordinate system for these, and I know globally I'm looking for, there it is, California, State Plane, North Zone. So it sets that. I'll take all these again, and I like to combine them into one layer so I don't get 5 or 6 layers showing up over here. I can control the image as though it were all those images as though they were one layer. So let's add those to the map to start. We've got a shapefile out there that's got some waterline information in our Redding, California area. So again, here's the image, the SID image, and we've seen this already. So let's connect to a shapefile. So we're looking for a waterline shapefile. Got the waterline information for this area. And the shapefile has the coordinate system embedded in it, so and that comes, I believe, in the form of a PRJ file that's associated with that shapefile. So I can add the waterline data to the drawing. And let me zoom to the extents of that layer of data. So there you see all the waterline information in that shapefile, and how it lays over our SID image. We can access information about this shapefile through tabular information through a data table. So there is a data table associated with this. And for those of you that are familiar with ESRI shapefiles, you'll know that this information is held in a DBF file. So this is a direct look into the DBF file for this particular waterline shapefile. I'm trying to drag this out a little bigger. At any rate, we have the ability to not only select information, waterlines in the drawing in this case, but we can also highlight a particular waterline in the data table and have it zoom to and be selected in the drawing. We can go the other way. If we were to select in the drawing, we get that record highlighted in the data table. Accessing this data is nice. It's very easy, very streamlined for, again, those of you familiar with working with shapefiles in previous versions of MAP before FDO was as robust as it is. You typically had to import that data. So you would take a shapefile, you would import it into MAP, and through that import you would get a translation of data from shape to DWG. And in that translation, you have a couple problems there. You have the ability to introduce errors in that translation. You also now end up with multiple silos of data. You've got a shapefile that represents this information. You now have DWG data that represents the same information, and keeping those in sync as data changes becomes very cumbersome. With the feature data object connection we see here, we connect directly to that shapefile, and again, I'm directly connected to that shapefile, so there's no translation, there's no conversion of data. This is the shapefile that I'm looking at, and it's rendered through Map3D. If I select one of these, take a look at the properties, you'll notice it's rendered as a map bulk feature. Not a lot of properties here. If I want to edit this data, and yes, you can edit directly in that shapefile, what I do is I check that feature out. It checks that particular segment that I've selected out of that shapefile. That checkout process prevents other users from accessing it, making edits to it until I'm done, and then I can change. Just a simple grip edit. It may be something more sophisticated. Once I'm done, I check that feature back in. I've now updated that shapefile directly. If some things in the data table need to change, I can change those as well. Maybe that is not a 6-inch pipe, perhaps it's an 8-inch pipe. I can update that DBF file as well. So that's all well and good. We have the ability to directly access information through FDO. We have the ability to edit it. We also have the ability to create it. So let's find another area here. Let's say I need to create a new water line in this shapefile for a subdivision that's going to happen. Maybe I already have it in DWG. In this case, I don't. I don't have any line work in DWG. But I can create or I can translate DWG information directly into this shapefile. In this case, let me just create here. I have the ability to create a new water line and turn on my OSNAPs. You'll notice that I've got all my very familiar CAD editing and creation tools. I'm not doing anything out of the ordinary here. It's just like drawing a line. I have the ability to put an arc on it, curved water line that might not make sense. Just demonstrating some of the tools. So I've created a new water line here. As I hit enter, it updates the shapefile. It brings me to the data table and says, hey, there's some data that you need to fill in for this. So I can go about manipulating this data and sticking with some conventions here. Oops. 8-inch, what type of pipe here? Looks like PVC is a supported type. I can't update the feature ID. That's an auto-generated number. This new feature ID will happen when I check this feature in. So as that feature now gets checked in, it generates automatically the feature ID, and now I have updated that shapefile directly as well as the DBF associated with it. Oops, did I just erase it? I think I did. Let me check all the features in here. There we go. So I just needed a refresh on that layer after I checked that data in. So again, very easy to consume data from other formats. Bring lots of data together to a single map. What else does AutoCAD Map give us over just vanilla AutoCAD? It gives us the ability to have cleaner, more accurate drawings. So let me open yet another drawing here. In this particular drawing, we're going to use some drawing cleanup tools to clean up some of the errors that might get introduced into a drawing through just general drafting or digitizing over a raster image, or maybe you've imported data from other sources. You have things like duplicate lines or duplicate entities on top of each other. You might have little undershoots. Maybe somebody was drafting without their OSNAPs on, so you have little lines that look fine at this zoom scale, they print fine, but truly they're not connected. They're not snapped together like they should be. Maybe you've got little overshoots that can be generated in the same manner. And these things have typically been tolerated in the CAD world, again, because they view okay. You know, you can zoom up pretty close and not see any undershoots or overshoots. They print okay, so they've been accepted. But when you start to come to the GIS world and you're doing analysis, maybe some kind of trace analysis, those little undershoots and overshoots can really mess up your analysis, as well as duplicates. If you've got 2 or 3 water lines drawn on top of each other, again, they print okay, they view okay, but when you do some analysis, like how much 8-inch water line do I have in this particular area, that one line gets counted 3 times because you've actually got 3 lines on top of each other. So an easy way to get rid of errors like that is using the drawing cleanup tools. So let's run some drawing cleanup on this particular drawing. The drawing cleanup is a wizard-based interface. The first page of this wizard wants you to select what objects you want to clean up. In this case, I know I want to clean up the water lines layer. What cleanup actions? I want to delete duplicates. Let's see. Let's extend undershoots and erase small dangling objects. And you'll notice that some of these things have a tolerance, so you can set a tolerance. What length of a line does it have to be, or object does it have to be considered a dangling object? How close to being snapped to another object does it need to be considered an undershoot? So those are options that you can set up with the tolerances. And let's make this interactive. We want to modify the original objects. There are some other options here. I won't delve too deeply into those. Another nice thing about this drawing cleanup tool is the ability to convert line work to polylines. So let's say you get a drawing from an outside contractor and they've drawn all the water lines using lines. You like to, in your organization, have all the water lines be polylines. So you can convert all those lines to polylines. You can convert arcs, 3D polylines. You can dumb them down to a 2D polyline, much lighter weight, circles, and finally arcs to polylines. So those are all things you can do with this cleanup wizard. You can use this cleanup tool to do just that without actually deleting duplicates or extending undershoots or anything like that. And finally you get your error markers. So let's finish this. And it in fact found 33 duplicates. So can you imagine being a drafter or designer having to work your way through this drawing and finding those duplicate objects? It would be almost impossible. Let's change the zoom scale here. So we zoom up close. And let's go take a look at the first duplicate object. So here we find a duplicate object, a line on top of a line. So I can choose to fix that one. It will take me to duplicate number 2. Looks like there were several duplicates there. Here's another one, error 3 of 33. And if you trust the software and you just want to get rid of all the duplicates in one fell swoop, you can highlight the upper level of that error and choose Fix All. So all my duplicates have been fixed. Now I've got some undershoots. I've got 145 undershoots. Again, we can work our way through those. Scroll up, very hard to see with just the naked eye that there's an undershoot there. I could fix that one, fix that one, fix that one. And again, if I just want to extend all the undershoots, if I want to fix them all and let the software do its thing, I can. Dangling objects, got 6 dangling objects. And let's say you're not sure about one of these. So you zoom up on this dangling object and you say, that looks like a water line stub to me. That doesn't look like a true dangling object. What am I going to do? Well, I need to talk to somebody about that. So I'm going to mark that one. So it just puts a marker on that for me in the drawing. And then I can move on to the next one. Number 2, that doesn't look like a duplicate, so I'm not going to fix that. I'm just going to remove that from the list. Number 3, I'll remove that. So you see how you can work interactively with this drawing cleanup wizard. And I'll just fix the rest of those and close out of this. So I've taken a drawing that had potentially many errors and cleaned it up very quickly. And I was a little bit speedy and probably not as thorough as you might be in a real world environment. But you get the idea that it's very easy to clean up a drawing using these tools. The next thing we want to talk about is building in some consistency to your data standards when working with Map 3D. And that consistency in the DWG environment can come through object classification. So let me open yet another drawing here. Classification drawing. So in this case, what we're looking at is perhaps a drawing that we've received, again, from an outside contractor. We've got polylines that represent the parcels. If I select one of these, we take a quick look at the properties. It's just a polyline, it's closed, it's on a new project parcels layer, but this doesn't quite meet the standards or isn't in step with the standards that I've got in my environment. So what you can do is you can build classifications, object classifications, that will enforce standards on a drawing like this. Let me check my layer status here really quick. So yes, here we go, parcels. So I like my parcels to be on a layer called parcels, not new project parcels. And true, I could easily select all these and change them to a new layer. But I'm going to let my object classification handle that for me, because object classification is going to do a little bit more for me. So you can see that I've built a classification already called parcels. And let's use it once, and then we'll take a look at the under the hood of this object classification. So I want to classify some objects, in this case parcels. I'm going to include objects with out of range properties, and I'm going to exclude objects that are already classified as something else. So let's just grab all my parcels as what I want to classify, and you'll notice that they changed color. They changed color because they changed layer. Now you'll notice that my polylines, my parcel lines, are now on the correct layer in my environment. What else do they have? They also have some real world data tied to them. Those of you that work in the AutoCAD environment, AutoCAD is great at drawing a parcel. AutoCAD is not so great at classifying or letting others know that that polyline, that closed polyline, represents a parcel. How would you specify that? You might put a label on it or something in AutoCAD, some text next to it that says this is a parcel, this is the area. But when you start to use map, AutoCAD map, to define these parcels, you have the ability to use object data tables. And that's what's been applied. Oops, select one. That's what's been applied here, an object data table called parcels. And in that object data table, think of it as a database table that the user can define what attributes go into it and what types of data those attributes can be. In this case, we've got acres, address, APN. Again, things that a regular AutoCAD user might not easily be able to specify on a particular polyline. Again, you'd have to use a label or something like that that's visible in the drawing. With map, you can use an object data table, so it holds this information behind the scenes and is only accessible when you want to use it. Oops. So let me log into map here. That's one of the idiosyncrasies of map. There's actually a login that gives you some more privileges, and one of those privileges is the ability to look at the properties of an object classification. So here's the object classification definition. It applies to all ACDB curves, so that's lines, polylines, arcs, circles. The property list, it forces a layer. So this is why I got that layer change. It forces a parcels layer on those objects. And here's the object data table and the attributes that are applied when something gets classified as a parcel in my case. So fairly powerful and fairly useful for those wanting to apply some standards to parcels. So let's see this happen again with water lines. Let me switch up my layer state here. Some of these are turned off or frozen. So let me turn on my water lines, and I'll turn off my parcels for the moment. So here's a set of water lines, and if I just grab one of these, you'll notice it's on a layer called New Project Water Lines. It's a polyline. Okay, there's no attribute data tied to it, but all that's built into my classification. So I want to classify some existing objects, in this case water lines. You'll notice that they all turn blue. Again, that's because they have been changed to a new layer, enforced in my classification standard, and now I've got some real world data that I can apply to this. So the size, the type, whether or not it's abandoned, and these are all editable right here. So maybe it's a 12-inch. Maybe it's not PVC, maybe it's steel, or so on and so forth. So all that data is now held in object data tables in map that I can access for things like analysis, things like creating labels, general user information. So very powerful tool, this object data, and the ability to build object classifications with that tied in. What if I want to create a new water line? What if I need to extend one of these? For instance, I might need to extend this one down here. it's as easy as now as creating a classified object. And that object has been created on the correct layer, even though that layer wasn't current. It's got the object data tied to it. It's got any other properties that I enforce on it already applied. So again, a very easy way to create standards and apply those standards not only to existing data, but to new data that you create. So I encourage you to explore that. Object classification is very powerful. The next topic, let's see, let's talk about the ability to work with data in formats other than DWG. I apologize, I tried to get Oracle Spatial running this morning. I just switched to a new computer and I'm having some hiccups here and there that I didn't have time to flesh out this morning. So I'm going to do this next demo in an SDF environment, but we'll pretend that it was Oracle, and if it were Oracle, it would be a very similar process. And so I'll try and point out those differences. So let me open yet another drawing here. So this drawing is called the database drawing simply because I planned on connecting to a database with it. Again, I already mentioned that I couldn't get Oracle Spatial up and running, but I do have a SID image applied to this. But what I want to do is show you how easy it is to not only connect to a database, and again we're faking a little bit, but it's also very easy to create new schemas in that database, new repositories for data that I want to add to it and consume from it. So as opposed to connecting directly to an Oracle database, I'm just going to build an SDF schema. And let's see, let's call this test. And this is going to be for the water lines. I can apply a coordinate system, and I'll just go with the one, it defaults to the one that the drawing is set to. And that will work in this case. So it throws up my schema editor right now, and it's just got a blank schema. It assumes you're going to build on this, and I can build new feature classes into this. Maybe I want to add a sewer feature class, a parcel feature class. And again, we can be working directly in a database here. In this case, we're working in an SDF file. But I've built the schema already, so let's import that schema and see what it consists of. And again, I built this schema just on the interest of saving a little bit of time, because we're about 45 minutes into the presentation here and we've got a little bit longer to go. So I'm going to bring this schema in. I'll delete that default schema that it threw in there. So here's my waterline schema with some data types already built into it. It defaults with a geometry data type. This holds the actual geometry that I apply for these water lines, so you can imagine it might be lines or polylines. It has a feature ID, an SDF ID number. It has a field I applied, whether or not this is abandoned, a size field, and the size field doesn't make much type for the data type to be a string. Maybe I want to use an integer for the size field, 6, 8, 12. And I also want to specify a list. Maybe I want users to not be able to just manually enter any size in. Maybe I want to constrain this to a list. So let's build a list. Here's my list editor, and let's say I want 6, I want 8, 12, 16, and 20. So I've built a list, and I could build a list for type, maybe string types of PVC, steel, so on and so forth. We'll just go with the size list. So now it's applying that schema, telling me there are no features in that schema yet, and that's okay. So if I click over to my display manager, you'll notice I'm connected already to that schema. Show the data table. There's no data in it yet, but I can begin to add data now. So let's create a new waterline line string. Let's move off to the side here. So there's that new waterline line string. Again, I'm working directly in this database, this SDF database. Is it abandoned? Again, these are fields that I built into it. No, it's not abandoned. What's the size? Here's the drop-down list I just built. So users can select from the list what type. Maybe it's PVC. Again, my SDF number is auto-generated, so I don't get to specify that. It happens when I check that feature in. So that's the first feature in this particular database. And so I begin to populate this database with information. So again, very easy to build these schemas, these data repositories, for you to start to add your own data to. The next topic, let's talk about the ability to generate 3D graphics. We mentioned this earlier in the presentation during the PowerPoint section. You can bring in three-dimensional surfaces like digital elevation models and drape other data over the top of it to get a very nice 3D rendered look and feel. So again, moving on to a new drawing. I'll just start a new one in this case. Map 2D drawing template is fine. And I'm going to connect to a couple sources of data. So as I mentioned to start with, we need a three-dimensional surface, a three-dimensional raster surface. And I've got that here in my Reading DEM. No, I'm sorry. I want to use my Duncan Mills Northeast DEM. So I'll connect to that. Sees the coordinate system. I'll add it to my map. So there we see it. Connect to one more source of data, again another raster, and in this case the raster is a TIFF for the same area. The coordinate system is applied most likely through a TIFF world file, for those of you familiar with georeferencing TIFFs. So there we see the TIFF laid over the top of the digital elevation model. We can now switch to a 3D mode, and we'll see that TIFF actually drape over the digital elevation model. So we'll give it a minute here to render itself, and there we go. So now we can zoom up, we can pan around, and we get a very nice three-dimensional look. And this new orbit tool is new in 2009, so you can just quickly pick different views and have it zoom to that, zoom and pan to that view. So a very nice tool, very easy to create three-dimensional look and feel using a digital elevation model in this case, but any kind of raster graphic will work. So Esri grids, other raster surfaces that are out there. Jump back to a 2D mode. And I'm going to, let me close all the drawings I've got open here. Not worried about saving changes to these. And I'm going to next show you the ability to work in a true multi-user environment with a single drawing. So let's get all these drawings closed, and let me open a drawing called Session 1 and Session 2. And let's tile these vertically so we get a look, and you'll notice that the two drawings look very similar to each other. The two drawings also have the same drawing attached. So this is through math. This is the way you work in that true multi-user environment with the same drawing. So you'll notice that Session 2 is connected to the city parcels drawing. Session 1 is connected to that same city parcels drawing. So let me execute a query, and that query is basically a request for information from that city parcels drawing. So here's the grid that it populated. Over here in session 2, I can execute that same query on the same drawing. So what we're looking at is essentially the same information from this city parcels drawing in 2 different sessions, 2 different users, essentially. So you have now the ability to work with this data at the object level. For instance, if I want to make a change, I as session 2 want to make a change to this particular parcel, maybe it's a simple grip edit, I'm prompted right away as soon as I change that to add this data to the save set. I can say yes. So this particular object is now locked for other users that might be accessing the same data. So if I come over here and I'm now session 1 down the hall and I want to try and make a change to that, as soon as I try and add that object to my save set, I get a warning. I can't add that to the save set. It's locked by another map user. In this case, it's me. So that object can't be changed by that user. Can't be added to the save set. And that save set is the intermediary between the drawing we're looking at here, this data that we queried, and the city parcels drawing. So how do I, as session 1, get access to the update from session 2? Well, session 2 needs to clear his save set by saving it back to the source drawing. So I'll go ahead and do that. I've got one newly created object. I'm sorry, one queried object right here. It tells me I've got one object in my save set. I'll go ahead and push that back. You'll notice it disappears from here. So I can re-execute this query and see that change. That change is now permanent. That change has been pushed back to city parcels. So I can come over here as session 1. Knowing a change has been made, I can re-execute my query. And I see the update that session 2 made. So again, working in a true multi-user environment, locking drawing objects at the object level, not the drawing level. Typically with AutoCAD, when one user opens a drawing, it's read-only for everybody else. So you now with MAP have the ability to work in a true multi-user environment. I talked a little bit about the ability to work with and edit metadata. So let me jump into yet another drawing here where we've applied some metadata. And bear with me here. Different menu sets have things in different, here we go, there's my metadata editor there. So we'll take a quick look at the metadata applied to this particular drawing. So we've got several sources that we can stylize this in different ways. I'll go with the classic. Here we see the basics, the summary of this. Let's edit, and we can edit this data. So lots going on here in the metadata editor, and this works not only with DWGs but with shapefiles, SDF files, any file-based format that supports metadata. You can work with it here. Right now I'm in the FGDC standard. There's also an ISO standard that you can apply. Many different tabs with lots of different information. So you can apply and edit metadata to drawings or other file-based information as you work with it. I won't save any changes because I didn't make any. So there's the metadata editor, and I'm speeding things up here a little bit because I do want to leave time for questions. Finally, let me open just one more drawing and I'll show you the ability to publish easily from Map 3D. And I did plan on publishing to Map Guide, but we're running out of time, so I'll publish to DWF. I'll open up the phone lines, and hopefully we've got some questions. We can talk a little bit about what Map Guide looks like. For those of you that haven't seen it, Map Guide is the web publishing tool from Autodesk. It allows you to publish maps very easily from Map here. I can just, it's a one-click, oops, need to be on the right tab. It's a one-click publish to Map Guide. I'm not going to do it again in the interest of time, but you can publish exactly what you see here out to a Map Guide site, and in literally minutes have an internet site that you can point users to that they can access this data through the web. So very cool. But let's talk about DWF. So publishing options in DWF. I have the option when I publish to DWF, the drawing web format, I can publish any map, any geospatial information. In this particular drawing, I've got a few shape files attached that have lots of meaningful attribute information. So I can put that into the DWF as well, and I'll do that in this case. So let me publish this to DWF. That's okay. Oh, and I don't want a multi-sheet DWF. So what I need to do is remove some of these from my publish list. I just want to publish one drawing in this case. If you have multiple drawings open, you can publish what's called a multi-sheet DWF, or if you have multiple layout tabs, a multi-sheet DWF. In this case, I just want one. I want to publish to DWF format, so let's go ahead and do this and see what we get. Put it somewhere where I'll be looking for it. So let's let that publish. It will happen fairly quickly. We'll take a look at that, and we'll take a look also at the ability to redline in that DWF, make some markups, and bring that redline information back into the drawing in which it was created. So this is a very handy tool for maybe you've got some designers that really don't draft very much, but they like to see the information, they like to mark it up. This is a way for you to get to the paperless markup state where you're doing design in Map or Civil 3D or AutoCAD. This particular functionality isn't specific to just Map. It's in all the Autodesk drafting products, AutoCAD, Civil 3D, Architectural Desktop, Revit, what have you. But you can generate these DWFs. Let's take a quick look at it now that it's done. You can bring these DWFs into a free viewer. It's called Design Review, and in that free viewer you have the ability to mark up these designs. You also have the ability to print. It's got the full AutoCAD print engine in the Design Review viewer. But let's talk a little bit more about the markup ability. So here we see the design as it was done, the map as it was done in AutoCAD Map. We've got many different sources of data, some DWG, some shape files, some images. We can toggle layers on and off, so I can turn off that image layer, maybe turn off the zoning information. You'll also remember that I published some of the map information. So for instance, on these parcels in this area, I can use my selection tool. And when it comes to life here, I can select one of my parcels. There we go, there's a parcel selected. And I see all the attribute information that came, in this case, from a shapefile, published through Map to DWF. So very, very powerful tool. And as I mentioned, we also have the ability to do markups. So let's build a rectangle callout. And let's pretty good size. Let me escape out of that and zoom out a little bit. It's a little bit weird because it's zoom scale dependent. So this is going to be very big. So maybe this is my markup. So we've put that markup in place now in our DWF. I can save this markup, and it obviously could have been a much more meaningful markup, and there could have been many of them. Save this. I'll close it. And now back in my map environment where I created that DWF, I can bring that markup in using my markup manager. So let's just quickly bring that markup in, and I'll show you the several ways to respond to that markup, and then I'll open the line for questions. So here we go, there's our markup. Let's see it in the design. There we go. So there's the markup now in my AutoCAD map environment, and I have the ability to, maybe it was back, I need to send it back for review, maybe it was an update, I can say, okay, this is done. I can now save this, republish the DWF, hand it back to the person that marked it up, and they'll see my changes, my responses. I can also add some notes. Yes, this is huge, or what have you. So very easy to go back and forth in a paperless environment and get that red line markup. So let me go ahead and unmute the phones, and we'll see if we've got any questions. So, do we have any questions out there? Okay, who is this? Hi, Bob. Good, how are you? Absolutely. Absolutely, and I don't think I have that drawing open anymore. I don't. But yes, that object classification is built as an XML file in the background, so you as the CAD administrator can build that object classification file with your parcels, water lines, sewers, and then move that XML file out to a network location and have users come here and attach that definition file where it sits, and then they'll have that list of definitions that you've built. Yes, but what you can do is you can set that up in a drawing template, so if you create a new drawing, it's looking for that XML file, but if you get a drawing, say from an outside contractor, the first time you open that drawing, you'll need to attach that definition file, but it will remain attached each time it's opened after that. It actually, as you build these classifications, it builds the file in the background for you. So, you know, I've got one that I've built here for another client. Let me just attach it real quick. Oops, not in there. Oh, let's see. There we go. So here's the XML file that I built. It just is out there as an XML file. It's an object classification file. So as I attach that, there's all the object classes that I've built in that particular file, in this case based on electric utilities stuff. So now it's available to me to use. So if I save this drawing, open it back up, this is still here. So that XML file is the key. So you want to put that in a shared location where all your users can access it, and they can attach it once to a drawing, and it will be attached until they choose to detach it. It doesn't need to be, no. It can be anywhere that's accessible. So no, you don't need to keep that XML file with the DWG. In this case, my XML file is in a different location as the DWG. But as you build new object classes into this, it continues to add to that XML file for you. There's no export or further steps you need to take. It builds that XML file as you build object classes. When you start, let's see, if I were to start a new one, a new definition file, I have to tell it where I want it and give it a name. So in this case, it's defaulting to the same location that I was last in through Windows Explorer for whatever reason. But I give it a name and a location. So you can start it off anywhere you want. Okay? Great. Any other questions out there? So let me just jump back to my PowerPoint slides really quickly here. I want to point you guys in the directions of some learning resources that have lots of good information. The user documentation is a good place to start. This should come with your Map 3D. It's the best practices guide. Lots of good information there. There's a GIS skills for engineers. This is free download from the Autodesk website. It's got a lot of good flash videos. You can watch the videos. It's got some hands-on tutorials and some data that goes with it. The new features workshop and the workflow guide are available when you launch MAP for the first time. Typically most people turn off the new features work guide, but you can get it through the help file, so it's always available through the help file. And speaking of the help file, it's been enhanced quite a bit. There's lots of good resources in the help file as well. We've entertained some questions. Do I have any other questions today? All right, with that, I will say thank you guys for attending today. There'll be a survey that comes out shortly. I don't know if it'll be today or the next couple of days, but please fill out the survey. It gives us valuable feedback, and it also gives you guys a chance to suggest topics for future webcasts. So with that, I'll say thank you, and I'm going to end the call. Everybody have a good afternoon.